charge will experience a force opposite to the direction of the field. Well, that must be very clear by now. Let's do a small problem. An electron has an initial velocity of 2 times 10 to the 6 meter per second in the x direction. It enters a uniform electric field E equal to 400 Newton per coulomb J, which is in the positive y direction. A. Find the acceleration of the electron. How long does it take the electron to travel 10 centimeter in the x direction in that field? By how much and in what direction is the electron deflected after traveling 10 centimeter in the x direction? Well, you know, can we think about it for a while? We have an electric field directed upward. Tell me, if you place a negative charge in that electric field, will the negative charge experience an upward force or a downward force? Well, a positive charge will experience a force in the direction of the field. A negative charge will experience a force opposite to the direction of the field. That means if you have a field that is directed upward and a negative charge comes into that field, it will experience a force opposite to that. Right? Now tell me, if I have a basketball here, if I throw it horizontally, what kind of motion will it have? If I throw it horizontally, it is going to go in a parabola like this. Is that right? There you are. So the basketball, if I throw a basketball in a gravitational field, this is going to go like this. Now the same thing is going to happen to the electron. Look at this. This is the electric field which is directed upward. So the poor electron comes up here, all of a sudden it gets caught inside the electric field. The electron will experience a force which way? Opposite to the direction of the field, downward. That means that electron is going to go exactly like our basketball. Why? Because the basketball experiences a force downward. The electron will also experience a force downward as it moves. So the electron is going to move like this. When it enters here, it will go like this. That means it will travel a horizontal distance x and a vertical distance y. Now, we have actually talked about these kind of motions when we did projectile motion. Well, we are going to use those concepts in here. Okay, let's put these things down. Well, this is the motion of the electron that we have been talking about. The initial velocity of the electron is in the x direction. You see, before it enters the electric field, the electron had an x velocity. It has no velocity in the y direction before entering the field. So we can say Vx0. What does Vx0 stand for? The x velocity before entering the field, or at the instant when it entered the field, is 2 times 10 to the 6 meter per second. That is given to us. Tell me, what happens to this x velocity as the electron enters the field? Let me see how many of you remembers the concept in projectile motion. You see, this electric field will not affect this x velocity. The electric field will only affect the y velocity. You see that? The x velocity will not be affected by the electric field. That means this Vx0, that is 2 times 10 to the 6 meter per second, will remain a constant as the electron moves through the electric field, because there is no force in the x direction. Vy0, initial y velocity is 0. And as the electron travels, its y velocity is going to increase. Just like the basketball falling, the electron will fall. Its y velocity will increase. Let's talk about it. Since the field is in the positive y direction, let's start with part A, then we will come back to the part C later. Part A, find the acceleration of the electron. Well, since the field is in the positive y direction, the force experienced by the electron is in the negative y direction. The acceleration in the y direction therefore is, alright, what is the formula for the acceleration we derived? A equal to Q over m times E. A equal to Q over m times E. What is the charge carried by an electron? 1.602 times 10 to the negative 19 coulomb. What is the mass of an electron? Can I remember it? Is it 9.1 times 10 to the negative 31 kilograms? Approximately, yes. The charge on the electron is 1.60 times 10 to the negative 19 coulomb. Mass of the electron is 9.109 times 10 to the negative 31 kilogram, times E is given to be 400 Newton per coulomb. And that gives me the acceleration of the electron. Look at this, it's a tremendous value. 7.03 times 10 to the 13 meter per second squared. Now, you must understand, I haven't given you the direction here. This must be negative J because it is directed downwards. This acceleration is in the negative y direction. So this is just the magnitude. You must understand that it is directed in the negative y direction. So the acceleration must be understood like this. Negative 7.03 times 10 to the 13 meter per second squared J. That is the acceleration of the electron. And now, with that acceleration, the electron is falling. But, before that, we must say the x velocity. The electron has an x velocity which does not change. The electron is going to travel in the x direction with that uniform velocity. That means if t is the time taken by the electron to travel 0.1 meter from, if suppose this is the origin, x equal to 0 to x equal to 0.1. The electron is going to travel like this. That means it travels the distance x equal to 0.1 in a time t, alright? And it has a constant velocity of 2 times 10 to the 6 meter per second. Can you find that t? Let me repeat that again. The electron moves with a horizontal x velocity of 2 times 10 to the 6 meter per second, and it travels a distance of 0.1 meter. What is the time taken for that? Well, that time will be t equal to x divided by the velocity. Is that right? X is 0.1 meter. The velocity is 2 times 10 to the 6 meter per second. And therefore that time is 5 times 10 to the negative 8 seconds, which is about 50 nanoseconds. So the time taken by the electron to cover a horizontal distance of 0.1 meter is 5 times 10 to the negative 8 seconds. During that time, the electron is falling vertically. We need to find that vertical fall. What is the vertical fall of the electron? Okay, so the acceleration of the electron, the downward acceleration of the electron is negative 7.03 times 10 to the 13 meter per second squared J, and the time taken for the electron to travel, the electron has been traveling for this many seconds. That means it has been accelerating at this rate for this much time. Now, can you give me an equation to find that vertical distance traveled by the electron? Y equal to Vy0t plus 1/2 AT squared. Have you forgotten that equation? Where Vy0 is the initial y velocity, which is 0. Therefore, y, the distance traveled by the electron during that time, will be 1/2 AT squared, where A is this value and T is this value. So let's put that in there, and that gives me 1/2 A times T squared. That is negative 0.088 meter. The electron will be deflected from its original path by a distance of negative 0.088 meter. Now, let me tell you, this is the most beautiful problem you will see in this part of the course. So try this one more time and try and understand how to do these kind of problems.